All right, so let's run through some examples for Chapter 11. This is profile control. So we're going to do some examples from the textbook. These are the application problems from the textbook, starting with problem number 25, which states apply a bilateral surface profile tolerance of 20 thou relative to datum feature A, primary, and datum feature B, secondary. Ensure the tolerance applies between the noted locations. Okay, so let's go ahead and kind of dissect this a little bit. So the datum features are going to be A, primary, B, secondary. Okay, there's no talk about maximum material condition in here, so we don't have to worry about that. And we're going to apply a surface profile, so that means we're going to use this symbol. We're going to use this symbol. Sorry, that's surface profile. This is line profile, profile of a line. So we're not going to use that. We're going to use surface profile. And it's bilateral, which I'll talk about as we apply it, and 20 thou. Right? Now, it also notes that we want to ensure the tolerance applies between the noted locations. So we're going to have to basically make sure that we're only talking about this surface right here. Okay? So let's go ahead and get this in. So we're going to go, the symbol is the surface profile. It's O20, right? No diameter symbol, because we're not talking about a cylindrical tolerance zone. And we're going to add the datum features here, or the datum references, A, primary, B, secondary. Okay, so now how do we control that it's between A and B? Now, first of all, how would we say that we want to go all the way around? Okay, well, there's a couple of things here. First of all, when a surface is clearly stopped at hard edges, then it's understood that it is just going to be that area. Okay, now we can be extra clear about this by pointing to this and saying, and here I'm just going to write over this because this is a nice arrow. We call this A. And we can call this B, right? And we're pointing to that corner and we're pointing to that corner. And we say, we include this little notation between A and B, right? With a double-headed arrow, all right? So that's how we denote it between this corner and this corner. So this surface profile, and because it's bilateral, that means that this O20 is going to be split on either side. Now I'm going to try to trace this out as good as I can. Right there. Right there. Okay. And this is, of course, 0.20 inches between, and from one side to the center is 0.010, half of that. Okay, so that would be the case of the equal bilateral, right? We'll talk about when it's unequal, all right? But real quickly, let's talk about how we would get it to be all the way around. So instead of the AB, what if we wanted to go all the way around? Well, we use this symbol right there. That is the all-around symbol. And it's taken from welding, right? And we just put it right in the elbow of that leader, and it's just a plain circle. If we do 2 concentric circles, then that means all over, and that takes in the 3D dimension of the surfaces. So we're talking about the front and back surfaces as well as the surfaces parallel to this or perpendicular to this point of view. Okay, so that's a pretty basic one, right? Number 25, we're just applying a bilateral surface profile relative to A and B of 020 between A and B here. All right. So now let's move on to number 26. All right. And number 26 says to apply an unequally disposed surface profile of 15 thou with the full 15 thou zone lying to the outside of the material. Okay, that is, it adds material, and that's going to be a key. Reference datum A and B, primary, secondary. Do not use the past practice alternate method. Okay, ensure the tolerance applies between the noted dimensions. Okay, so there's going to be a lot of similarities to the one that we just did. All right, so we're going to have datum references A and B again. We're going to have a extent between, and here I'll be a little bit different. I'm going to say X and Y, right? We can do that. So we're going to include that notation, right? But here we want to figure out how to do this unequally disposed with the full 15 thou zone adding material, okay? So we're going to use this symbol right here, this unequally disposed symbol. And it's basically going to be positioned right where the MMC, maximum material condition symbol, is going to be. And this always represents material to be added. Okay? So when we want to add all of this material, so this 15 thou zone lies all on the outside. That means we're adding material to it. We're going to use the U symbol and the O15. Okay, so it's going to look like this. This is a surface profile, so we're going to use this symbol again. We're going to go O15, right? And then we're going to use the circle U. And then we're going to say how much of the tolerance adds material. Well, in this case, we're told that all 15 thou adds material. And then we're going to say A, B, and then we're going to say between X and Y. Okay? Whoops. Let me add that on the end there. Okay? So remember, the U symbol represents the amount of material that we're adding in the tolerance zone for the unequally disposed surface profile. We're told that we're adding 15 thou. So what does that mean? That means essentially that the tolerance zone is going to look like this. The tolerance zone is going to be like this with all 15 thou on the outside. Okay? If we did not have the circle U 0.015, then it would be halfway between 0.015 and then let's see if I can do halfway between. Halfway would be 0.0075, right? What if we wanted to do all on the inside, right? So in what we would want, what if we wanted this kind of a tolerance zone where all of the 0.015 is going to be on the inside? Well, what would that be? That would be a U 0.000 0.015 A, B, like so. Right? So this says that how much is going to be on the outside. Remember, this represents how much is on the outside, material to be added. We're adding 0 to the outside. That means that all of the 0.015 goes to the inside. And we can make any combination, like that. If we wanted 10 on the inside and 5 on the outside, then it would be circle U 0.010. That would be 10 on the outside And of the 15, that would leave 5 on the inside. So we'd have an unequal tolerance zone that would look something like that. Okay? So just remember the circle U represents the amount of material to be added using this as the total amount that we have at our disposal. Okay? All right. So let's move on now. We'll move on to problem number 27. All right. Now, problem number 27 says apply a surface profile tolerance of 18 thou all around the cutout. All around the cutout. That's the key word. All around. Relate the tolerance to datums A primary, B secondary, C tertiary. Datum features B and C should be regardless of material boundary. Okay. And we can do B and we know that B and C are datum features of size because we can see that the little plunger or whatever you want to call it, the plunger is directly opposite the arrow, So that means that these are datum features of size. And of course, we can only apply RMB, MMB, and LMB to datum features of size. Okay. So, we have a tolerance. We're going to use a surface profile tolerance. So let's put the surface profile tolerance in there. The tolerance is 0.18, and we're not told that it's unequally disposed, so we're just going to assume that it's equally disposed. So it's 0.018. All right. Relative to A primary, B secondary, and C tertiary. Of course, because it's RMB, regardless of material boundary, then there are no data modifiers in there, right? Now, what about this all around? Well, we already talked about that. We want basically our tolerance zone to be all the way around this cutout. So, go right there. Okay. Now, as a little side exercise, we have an 18 thou tolerance zone, but what if we wanted, and the tolerance zone is split 9 thou inside and 9 thou outside, right? Because it's equally disposed, it's split halfway between that. What if we wanted all of this 18 thou to be on the inside? In other words, we wanted this kind of situation, right? 0.018, all right? So we know right away we're going to use the U, all right? Now, how much material are we adding to this? Well, since this is a cutout, we would be adding material to this cutout, right? We're making the cutout smaller, therefore we would need to add material to the cutout. And the circle U represents the amount of material added, so this would be 0.018. I'm gonna label this 1 so that we can keep track of that 1. So our symbol, our feature control frame, would be just like that. Now, what if we wanted it to be on the other way? What if we wanted all 0.018 to be on the outside? Then this would be an example of when we would be removing material, right? If we make this whole opening larger, then we would be removing material from its status right now. So we'll call this 2. 2 would be circle U, 0.000. That means all of the material is going to be removed, right? Because remember, this is the amount of material that we're adding. How much are we adding to it? We're adding 0. That means we're subtracting 0.018. So it would look just like this, 0.000, A, B, C. And just for interesting sake, let's say that we wanted it to be 0.007 on the inside. Right? So we would be adding 7 thou. Another way to think of this would be the same as 0.011. These are the same. Let's number that 3, and let's say what would that look like? Well, how much material are we adding? We're adding 7 thou. So our feature control frame would look just like this. Right? That's the same, right? That's the same. How's the tolerance zone shift? Well, it's the amount of material that we're adding. So there you go. All right, so there's 3 examples of that. Don't forget the all around symbol, which basically means that our tolerance zone is going to go all the way around this, like so. Okay? Great. Moving right along, let's look at problem number 28. All right? Now, this is going to be kind of similar, right? Apply a surface profile. Let's change this to a line profile, just to get things to be a little bit different. Apply a line profile tolerance of 20 thou relative to datum A primary, datum B secondary. Limit the application to the surface area between the indicated points. Okay, so this is nothing new, right? So we could point to this surface like so. We're going to use our feature control frame. We're talking about a line profile, so it's not going to have the bottom on it. 0.020. It's equally disposed, right? So there's no talk that it's not equally disposed relative to A and B. And then we want to say between, let's call this M and N. So between M and N. All right, that's it. Very straightforward, right? Hopefully you're seeing, how we apply this, and certainly with the unequally disposed. All right, let's see how many we have left. I think we have a couple left, so let's continue on with our application problem. Okay, so this one's going to be a little bit more challenging, okay? So what we have is we have an object with 3 kind of what we might call boss pads, little pads right here, 1, 2, 3. And they're all controlled in the same line through the application of these extension lines connecting these surfaces. And it says, use a composite profile tolerance to control 3 surfaces to be coplanar and oriented to datum feature A within 8 thou and located to datum feature A within 20 thou. Okay? So we have coplanar and oriented. And we have located. All right? And the coplanar and oriented is the 8 thou. And the located is the 20 thou. Now, this is an application of a composite profile tolerance. Right? And that's where we're going to have a double feature control frame. Whoops, I kind of goofed that up. There's not a line in between where we have one symbol, right? Sorry about that. One symbol. And then we have an upper and a lower. Okay? The upper is going to be the location control. So this part is location. The bottom part is going to be the coplanar and the oriented, depending on how the datums are used. Okay? And you can see the variation in your book about how the datums are used. Let's go ahead and apply this here. So we want to point to a surface here. And I'm going to have to be careful to squeeze this in, okay? Now, we want to be clear that we're talking about 3 surfaces. So we can't just put the feature control frame here. We want to add the multiplier 3 times. All right. Now we can add it there or we can add it underneath. I don't have enough room to add it underneath. I'll show you down here how to do that. But then we want to do the composite feature control frame with 1 symbol. It's a profile of a surface profile. And the top is going to be the location control. So that's going to be 020. A good way to remember this is that the larger number always goes on top, whether it's a composite profile, composite positional tolerance, the larger number always goes on top. All right. And we want it, location means that we have to be locating it relative to a datum. All right. So A. Okay. Now, the bottom part, we already know it's going to be coplanar and oriented. The coplanar part, if it was just coplanar, then we would be done, right? Let me cover that up. No line there, no datum. If it's just coplanar, then we have the 8th thou in there with no repeated datums. But because we want it to be oriented, and what that means is we want these surfaces to be coplanar and also parallel to A, we need to repeat the A because it has to be oriented to what? To what? Right? We don't say coplanar to what. Coplanar is, by definition does not need a to what. We need to be oriented to what, and we need to be located to what. And whenever we have a to what, then that's a datum. Right? So there's your answer right there. Okay. Oh, one more thing. Sorry. We must include a basic dimension. All right. So we need to locate this, right? Remember what we're doing here is we are locating the tolerance zone. So that this basic dimension locates the tolerance zone right here. There's our tolerance zone. 0.020. Right? And that's what that 750 basic does. It locates the tolerance zone. So this tolerance zone is fixed in space. It's located, it's anchored right at that 750 above datum A. Okay, so that was a little tricky. Hopefully that that made sense to you. And the last one we're going to look at, problem number 30. All right, and problem number 30 is a little bit similar. It says control the 3 surfaces to be located, oriented, and coplanar. Okay, so now located, oriented, and coplanar within the 12th thou tolerance zone relative to datum A. All right, so this is actually going, because we're combining all of the controls into one, location, orientation, and coplanarity, this is not a composite positional tolerance, or excuse me, a composite profile tolerance. So this is just a single feature control frame, surface control, 012 relative to A. Very straightforward. We want to say 3 surfaces. So this is the other way to call this out. All right. So here we did a 3x. And here we're just going to call it out here. I didn't do it on the other one because there just wasn't any room. And because we're locating it, this must be basic. Okay, so those application problems, I hope that kind of maybe dispelled some confusion that you might have had with these. You see how we apply that, some of the things that you need to remember. If you have any questions, please email me. Okay? Good luck with this.